Okay, my group is me, Haley Tilton, and Charles Davis, or Chuck Davis. And in Lab C, the uncatalyzed rate of decomposition of hydrogen peroxide, or H2O2, we're going to determine the rate that hydrogen peroxide spontaneously decomposes when exposed to room temperature and ambient light for a 24-hour period. But the hydrogen peroxide that we have at school, it's been there for more than 24 hours, but that's all right. So we're going to put 10 milliliters of that into a beaker, a beaker. And then we're going to take 1 milliliter of distilled water, which is going to replace the catalase. So instead of using catalase, we're using distilled water. We're going to place that in. And then after that, we're going to titrate it with potassium manganate, or KMNO4. Yes. And we're going to use that, and we're going to take the initial volume of the KMNO4, or potassium manganate, and we're going to put that we're going to take the initial volume of that, and then we're going to keep adding drops until the solution of hydrogen peroxide and distilled water turns pink or brown, and it stays pink or brown after we mix it. And after that we'll use the initial volume and the final volume, and then we'll subtract the initial volume from the final volume, and that'll give us the change in volume, and that'll be the amount of hydrogen peroxide left in the solution after 24 hours, or however long we've had that hydrogen peroxide in the class. And and that's the amount of hydrogen peroxide that has decomposed, and that's equal to the baseline determined in activity B, which is determining the initial baseline amount of H2O2 in a solution, which is hydrogen peroxide. And so the amount of hydrogen peroxide that spontaneously decomposes at room temperature would be the initial, or the change in volume of milliliters per 24 hours, or however long we've had the solution. Yeah, that's activity C, Lab C, the uncatalyzed rate of decomposition of hydrogen peroxide.